Hi, this is Shannon from SIS4teachers.org. Thanks so much for joining us. Today we're going to be talking about, in this tutorial video, subtracting fractions with uncommon denominators. Instead of just showing you in the abstract, we really want to have a visual for you to understand concretely or pictorially what this looks like in your head. I love to use different things for fractions, such as pattern blocks. In our previous videos, we did a video on subtracting with common denominators. I showed that with pattern blocks. I also like using our area model papers or even petty paper to demonstrate. We want to make sure that you understand really the why before the how when you're doing fractions. In this demonstration today, I'm going to show 7/8 minus 4/16, but I'm going to use our area model papers. Our area model papers have different pieces of paper that are cut out to equal fractional parts. So our orange in this case equals 1/2. Our yellow in this case is going to be equal to 1/4. And then our pink is going to be equal to 1/8. We could fit 8 of those on our total. And then we're going to use 16ths to show the parts to show 16ths. So what I'm going to first do is just see, do we understand what the problem's asking? Let's show first what it's asking. It's asking us to look at 7/8. 7/8, I know that one more eighth would total the whole that we have, and it's asking us to take away 4/16. Unless you understand a lot about equivalent fractions or have worked with the patty paper before, you might not really know quite what to do. You could try to change the pieces, they're the same denominator, to make it so you can take it away, but in this case, does it have to be 16ths? We oftentimes hear maybe our parents saying, skip count by the number and find the common denominator, but we're going to talk about in this video that is the only common denominator that we could work with 16ths. Let's try that at first. Let's just try to rename our 7/8 into 16ths. I'm going to put my fraction over 16 and let's discover how many 16ths is 7/8. So I'm going to go ahead and put these on top. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Wow, 14/16 is total equals the same as 7/8. By a layering system, by keeping the whole underneath, you can really visually see how these are really equivalent. I'm now going to take away that 4/16 and see what I get for the answer. So in this case, I'm going to go ahead and take away my 2/16, and I'm going to take away another 2/16. So we have 4/16 that we're taking away, and we see that we're left over with 8, 9, 10/16. If you're using this for classroom use as a lesson launch or even as a flipped classroom concept, I want you to see if you noticed something. As I was pulling these away, I was pulling the 16ths away. Is there a different way that we could look at this problem? This is exactly right, but your teacher's probably going to tell you, wait a minute, this isn't reduced in its simplest form. Are there other equivalent fractions that equal the 10/16? So let's think about what else we could do to solve this problem. We could go ahead and reduce it and figure that out very easily, but let's see if we kind of thought about that denominator being different and maybe taking one step that we're doing and changing it. So I'm going to take the 16ths and take them off of what we're doing, and I'm going to leave the eighths up the way that we saw it. Okay, and so this is one option. That would be certainly an easy way, but kind of thinking outside the box, do you notice anything? What did you notice when you paused the video and talked about what we were pulling away here? What did you notice when we were putting the 16ths on top of the eighths? Did you notice that our 4/16 actually equals 2/8? So let's say I decide to look at this differently and I want to change my 4/16 to an equivalent fraction, and in this case I know that it's worth 2/8. So is this problem a little bit simpler? Do we have one less step? Maybe. Let's check it out. So if we were to look at this, knowing that we've just changed the name of these 2/8 and we've made them 16ths, I have 7/8. I'm going to go ahead and take away my 2/8, which is equal to the 4/16, and I'm going to count to see how many eighths I have left. I have 1, 2, 3, 4, 5. So the answer here is 5/8. This is the same as what we had with the 16ths, but it's reduced into its to sort of its simplest form. Is there a piece that we could put over top that we could make this even simpler? No, we probably can't because it's not going to go equally. If I go to put my half on top, no. The other one that we came up with earlier was the 16ths, and we already know that it was 2, 4, 6, 8, 10 16ths. So both of the answers, 10 16ths and 5/8, are equal to this answer, but we know that this is in its reduced form. Sometimes when we're taking tests, we always don't see it in its simplest form. We hope this video helped you to kind of understand subtracting fractions with uncommon denominators in a really abstract way, but also with the understanding of how you could explain it in the concrete or the pictorial way. It's really important for you to practice this in your classroom. After this video, we'd love for you to try out other fractions that you could use with a manipulative in your classroom. Maybe you could create some for your class. You're welcome to use this video as a launch to learning subtracting fractions with uncommon denominators, or you can use it in a flipped classroom concept where students can listen to it prior to coming with the Math of the Teacher station. Have them use the manipulatives, talk with the group that they're with as they're learning about the new concept before they come to see you. Be sure to check out our other videos in our whole fraction series, but specifically with fractions, we'll be talking about how to subtract when you're looking at it from a whole number, and we'll also be using our friend Springling. We also have a video that we did on subtracting with common denominators. Be sure to check out our website at sis4teachers.org or our YouTube channel, which is at the same handle at sis4teachers. Thanks so much for joining us.